stare into this blackness. For most of us, space is just beautiful pictures of nebulae and distant galaxies. But the reality is far more ruthless. It is the absolute rain of cold and radiation. An ocean without a single drop of water, where the distance between island stars is measured in trillions of miles. We, beings born in the warmth and comfort of an atmosphere, have always feared this darkness. But it is in human nature to have something that compels us to step into that darkness. Today, as we record these words, two objects are flying at an unimaginable distance from Earth. They are the fastest, farthest, and loneliest creations of our hands. These are the Voyagers. They are beyond the reach of the solar wind, where the very concepts of day and night lose their meaning. Originally, the journey was planned for only 5 years. However, the machines exceeded all expectations. They remained in service while world leaders changed and old regimes crumbled. Now we will trace the story of how technology from the distant 70s became a symbol of our immortality. This is an echo from the void, unceasing for nearly half a century. To understand the magnitude of this feat, we must go back to the early 60s. Space was terra incognita to us. We had barely learned how to enter Earth's orbit. Flight to distant planets, Jupiter, Saturn, seemed impossible. The problem was fuel. Rockets of that time were too weak to deliver a heavy spacecraft to the outer reaches of the system. A direct flight would have taken decades. But in 1961, a young mathematician named Michael Minovich, working at NASA's Jet Propulsion Laboratory, made a theoretical breakthrough. He realized that a spacecraft could steal energy from planets. This is called a gravity assist maneuver. By using the gravity of a massive planet, a probe can accelerate and change direction without a single drop of fuel. Jupiter, this gas giant, could become a cosmic slingshot. 1965, Gary Flandreau, using these calculations, discovered something both terrifying and beautiful. He found that in the late 70s, the giant planets would align in a rare configuration. This happens only once every 176 years. The last time this occurred, Napoleon Bonaparte was marching against Russia. The next chance wouldn't come until the 22nd century. This was the Grand Tour project. The original plan was ambitious: launch 5 spacecraft to Jupiter, Saturn, Uranus, Neptune, and Pluto. The cost was estimated at $1 billion, a staggering sum for that time. The United States Congress was horrified. In 1972, the project was officially cancelled. But NASA scientists did not give up. They used a tactic that would later be called engineering guerrilla warfare. They proposed a modest mission called Mariner Jupiter-Saturn to only 2 planets. The price was 3 times lower. Politicians agreed. However, the engineers, unbeknownst to management, built into the design the capability for a much longer journey. They built the craft so that after Saturn, they could fly further. Thus, Voyager was born. Let's look under the skin of this machine. It's not a modern iPhone. It's technology from the disco era and the first CRT televisions. The weight of each Voyager is 821 kilograms. Of this, 105 kilograms are scientific instruments. The most striking detail is the massive parabolic antenna, 3.7 meters in diameter. It is the only way to talk to home. At a distance of 20 billion kilometers, the signal from this antenna reaching Earth has a power of 1/10 billionth of a watt. That's 20 million times weaker than the battery in your wristwatch. There are no solar panels inside Voyager. At Jupiter, sunlight is 27 times weaker than on Earth. At Neptune, it is 900 times weaker. Solar panels are useless there. Instead, RTGs, radioisotope thermoelectric generators, are used. Inside each of the 3 black capsules is plutonium-238. Its natural radioactive decay generates heat, which thermocouples convert into electricity. At the start of the journey, they produced 470 watts. This was barely enough to power a few light bulbs. Today, 49 years later, the power has dropped to a critical 230 watts. The machines are slowly cooling down. But the most amazing part is the computers. There are 3 dual redundant systems on board. First is the CCS, Computer Command System. This is the central brain. Its memory is only 8 kilobytes. For comparison, one modern photo on your phone is 1,000 times larger than Voyager's entire memory. Second is the FDS, Flight Data System. It is responsible for collecting and packaging scientific data. Third is the AACS, Attitude and Articulation Control System. It manages the craft's orientation in space. The programs were written in pure assembly code, where every line was a battle for bytes. Engineers couldn't afford a single unnecessary command. And it is this ancient code that is saving the mission in interstellar space today. Carl Sagan understood the Voyagers would be Earth's first ambassadors to ever leave our bubble. They are messages in bottles cast into the cosmic ocean. The probability of someone finding them is vanishingly small, but it is not zero. Sagan's team created the golden record. It is a 12-inch copper disc plated with gold. Inside the case is a phonograph needle and an ultra-pure sample of the isotope uranium-238, so that aliens could determine the craft's age by its decay period. The record's content is an anthology of our civilization. 115 images, a DNA diagram, a pregnant woman, mathematical formulas, the Egyptian pyramids, greetings in 55 languages, the oldest in Sumerian, the language of Earth's first civilization, the most modern in the Amoy language. But most important was the music. 90 minutes of the planet's greatest sounds. Bach, Beethoven, Indian ragas, the Japanese shakuhachi flute, and of course, Chuck Berry with his high-energy Johnny B. Good. Legend has it that when Sagan suggested including rock and roll, some NASA officials objected, calling it vulgar. Sagan replied, "There are plenty of stars in the universe, but rock and roll is the unique noise of Earth." On the record's cover, a map of stellar pulsars is engraved. 14 cosmic landmarks, pointing the way to our sun. Some critics said it was dangerous to reveal our location to potential invaders. No, Frank Drake, Sagan's associate, replied, "Any civilization capable of intercepting Voyager in interstellar space already knows where we are. This is not a map for enemies. It's an invitation for friends." On August 20th, 1977, from Launch Complex 41 at Cape Canaveral, a Titan IIIe rocket roared into the sky. On its tip was Voyager 2. Yes, number 2 was launched first because it was flying a longer, slower trajectory. 2 weeks later, on September 5th, Voyager 1 took off. Its launch nearly ended in tragedy. The rocket's second stage shut down 3.5 seconds early due to a fuel leak. Voyager 1 began to fall back into the atmosphere. only because the Centaur upper stage had a smart control system was it able to compensate for the lack of speed, burning fuel to the very last drop. The craft entered orbit with only 1.5 seconds of fuel remaining. Had the leak been slightly larger, the greatest mission in human history would have ended as a pile of scrap at the bottom of the Atlantic Ocean. The first months of flight were an engineer's nightmare. On Voyager 2, the instrument boom jammed. It didn't deploy fully. Scientists spent hours rocking the spacecraft, pulsing the attitude thrusters until the latch finally clicked. Then, the primary radio receiver failed. The backup receiver was also damaged. Its automatic frequency tracking system had broken. Now, the craft could only hear Earth in an extremely narrow frequency window. If the temperature on board changed by just a couple of degrees, the frequency would drift, and Voyager 2 would be deaf forever. Engineers had to create a special program on Earth that calculated the exact transmission frequency, accounting for Doppler shift and the temperature inside the probe. This struggle for communication continues to this day. In March 1979, Voyager 1 entered the Jovian system. What scientists saw on their screens revolutionized astronomy. Jupiter turned out to be more than just a striped ball. It was a boiling cauldron of hydrogen and helium. The Great Red Spot, a giant storm larger than Earth, proved to be a complex system of counter-rotating flows that had been swirling for at least 300 years. The Voyagers saw lightning in Jupiter's atmosphere for the first time. Each flash was hundreds of times more powerful than those on Earth. But the real shock was the moons. Before Voyager, we thought planetary moons were dead ice rocks like our moon. When the images of the moon Io arrived, scientists at first thought dust had settled on the craft's lens. Io's surface was bright yellow, orange, and black. It didn't have a single impact crater. Linda Morabito, a navigation specialist, noticed a strange cloud over the edge of the moon's disk. It was an erupting volcano, a massive plume of sulfur shooting 300 kilometers into space. It turned out that Jupiter, with its monstrous gravity, was literally kneading Io's interior, heating it to a liquid state. For the first time, we had found a living, geologically active world outside our own planet. Then came Europa, a smooth ice ball, crisscrossed by strange brown lines. The Voyagers provided the first evidence. Beneath this ice, tens of kilometers deep, lies an ocean of liquid water. There is more water there than in all of Earth's oceans combined. Where there is water and heat from gravitational tides, there could be life. The Voyagers turned astronomy from a science of points of light into a science of habitable worlds. In late 1980, the first spacecraft reached Saturn. We saw its vast systems of ice and dust shining in the rays of the distant sun. It turned out these disks were not 7, as previously thought. There were thousands, trillions of icy fragments, from microscopic dust motes to boulders the size of houses. The Voyagers saw spokes, strange dark structures within the rings caused by the interaction of dust with the planet's magnetic field. Here, the mission team faced their toughest choice. Saturn has Titan, the second largest moon in the solar system. Scientists knew it had a thick atmosphere, consisting mainly of nitrogen, like Earth's. Carl Sagan and his colleagues were obsessed with Titan. They believed it was an Earth in deep freeze, where pre-biological chemical reactions might be occurring. But there was a problem. To see Titan up close, Voyager 1 had to fly a trajectory that would fling it out of the plane of the ecliptic. This meant it would never encounter another planet again. It would not be able to fly to Uranus or Neptune. The scientific community was split. One group wanted to continue the grand tour to the outskirts. The other demanded the study of Titan. Titan 1. On November 12, 1980, Voyager 1 flew just 6,000 kilometers from the orange moon. The cameras couldn't pierce the thick smog, but instruments confirmed lakes of liquid methane and ethane might exist on Titan's surface. It was a triumph. No, there was a price to pay. Voyager 1 said goodbye to the planets forever and began its long climb upward into the void. All responsibility for completing the grand tour fell to Voyager 2. And it did not disappoint. After Saturn, Voyager 2 was alone. It had to fly where no human machine had ever been. The distances were becoming colossal. Uranus is twice as far from the Sun as Saturn. It takes light nearly 3 hours to travel from the star to the planet. In January 1986, Voyager 2 approached Uranus. Before us appeared an azure world that literally lies on its side. Its axis is tilted 98 degrees. Scientists saw a featureless sphere. But beneath that serene surface lay secrets. Voyager discovered that Uranus's magnetic field is offset from the planet's center. Another 3 years of icy silence passed. In August 1989, the craft reached Neptune. Here, engineers had to perform miracles of ingenuity. Light at Neptune is 30 times weaker than at Jupiter. The cameras required long exposures, but at high speed, the images would inevitably blur. Scientists taught Voyager 2 to perform a compensation maneuver. During the shoot, the entire spacecraft would slowly rotate. And the result was stunning. The craft captured ice geysers on Triton, shooting plumes of nitrogen. The grand tour was officially complete. Humanity had seen all the outer worlds for the first time. In mid-February 1990, Voyager 1 had already left the orbits of the planets behind. It was 6 billion kilometers from Earth. Carl Sagan convinced NASA to take one last farewell photo. The craft turned its camera back toward the distant suns. It took a series of 60 frames. And there, amid bands of scattered light, it was the pale blue dot. It occupied only 0.12 of a pixel. On that tiny speck resided all the oceans, mountain ranges, every empire, and every dream of our species. Carl Sagan wrote words about this image that became a manifesto for humanity. On that mote of dust, suspended in a sunbeam, lived everyone you love, everyone you know, everyone you ever heard of. It is our home. Our responsibility is to preserve this pale blue dot, the only home we've ever known. Immediately after these commands, the cameras on both Voyagers were turned off forever. They had nothing left to photograph. Now they became blind wanderers, navigating only by the stars and magnetic fields. The next 20 years were quiet. The machines raced through the heliosphere. Scientists argued for decades. Where is the edge of our system? In 2004, Voyager 1 passed the termination shock. But the real battle happened on August 25, 2012. The sensors showed something vital. The flow of particles from our star had almost vanished. Voyager 1 had crossed the heliopause. It had entered interstellar space. Voyager 2 followed in November 2018. Space turned out not to be entirely empty. There is a dense layer of small particles there. This shield protects our Earth from the dangerous rays of the cosmos. Without it, life would be impossible. Our machines now work as scouts in this deep and cold space. By the early 1920s, the Voyagers had become aging seniors. Their parts, designed for 5 years of work, had been functioning for 50. Because of the cold, the electronics began to fail. In November 2023, a disaster occurred. Voyager 1 stopped sending intelligible data. Instead of orderly rows of telemetry, Earth received an endless loop of the same meaningless binary code. Cosmic Alzheimer's, that's what the engineers called it. For 5 months, the NASA team worked 24 hours a day. Each message took 22.5 hours to reach the craft. The same was required for the reply. A single hello took 2 days. They discovered that on the FDS Flight Data System chip, only 3% of the memory had failed. But it was in those 3% that the code responsible for packaging all scientific information resided. Engineers took an insane risk. They decided to rewrite the 47-year-old program, break the damaged code into pieces, and move them to other, still healthy parts of the memory. In the spring of 2024, 24 billion kilometers from home, this hack succeeded. Voyager's voice returned. It was the most remote and complex software repair operation in human history. But in 2026, the situation became even more difficult. The atomic heart is producing less than 220 watts. Engineers had to turn off the heaters for some instruments. On Voyager 1, the temperature inside the chassis dropped to minus 30 degrees Celsius, below the limits its creators ever calculated for. Now, in the summer of 2026, NASA is preparing for its most dangerous operation, codenamed Big Bang. To save the last scraps of energy for the radio transmitter, engineers plan to completely rebuild the power distribution system on Voyager 2. They are going to disconnect the protective relays that prevent power surges. This is an extremely risky step. If all goes well, the craft will gain a few more years of life. If there is the slightest glitch, a short circuit will instantly turn Voyager into a block of dead ice. Why such a struggle? Because in November 2026, Voyager 1 is scheduled to cross a historic milestone, a distance of 1 light day from Earth. That is 25.9 billion kilometers. The distance light travels in an entire day. We want to be with it at that moment. We don't want it to slip into the darkness in silence. By approximately 2032 or 2035, the energy will be completely gone. The final radio pulse will reach Earth, be decoded by the giant dishes of the Deep Space Network, and then there will be silence. Forever. But this is not the end of the story. In the vacuum of interstellar space, there is no erosion. There is no oxygen to cause rust, and no wind to erase symbols. In 40,000 years, Voyager 1 will pass within 1.6 light-years of the star Gliese 445. In 296,000 years, Voyager 2 will approach Sirius. They will fly for billions of years. They will outlive the birth and death of new species on Earth. They will exist when our sun turns into a red giant and swallows our home. On board, each of them hangs a golden record. And even if no one ever finds it, the very fact of its existence means that we were here, that we loved, that we created music, that we reached for the stars. The Voyagers are not just machines. They are our footprints in the sands of time, which the tide will never wash away. We are the only beings on Earth who have sent a piece of ourselves into eternity. And while an atomic heart beats somewhere out there in the gloom, our story is not over. End of communication. But the journey continues.